Hey everyone, welcome back to my YouTube channel. So in today's video, we're going to discuss how to implement Caesar Cipher in Haskell. So Caesar Cipher is basically a primitive method of encoding messages by shifting each character in them by a fixed number of positions mentioned in the key. So what happens is that let's say we have a sample text A, B, C, D, and we pass in the key, let's say 1. This can be any numeric value, the key. What happens is that I take each character in the string and I shift it by one position. The position is determined the key. Here I shift it by one position because the key is 1. So what happens? A becomes B, B becomes C, C becomes D, D becomes E, and this will be our encrypted text, and this will be our original text. So how to decrypt it? We decrypt it by shifting it in a reverse manner. So let's say we encoded it by shifting it in plus key positions. We decrypt it by shifting it in a reverse number of positions. So let's say B becomes A, C becomes B, D becomes C, E becomes D. So this, we get the original text back. So I assume by now you have a basic understanding of how Caesar Cipher works. So now let's talk about how to implement it using Haskell. So we're going to create two functions, encode and decode, which encrypts the message and decodes the message respectively. Now before coding it up, let's think about functionally how the function prototype will be. What will be the function's inputs and output of these two functions? So let's say the inputs of encode will be a key, and then it will accept original text, and the output will be the encrypted text, right? And what about the decode function? It should take a key similarly and an encrypted text because we are decoding, remember? And what will be its output? It will return the original text. So what will be its function prototype? So the encode function will accept an integer, which is the key, and a string, which is the original text, and return the encrypted text as a string. And what about decode? Well, for decode, similarly, we accept an integer, encrypted text as a string, and it returns the original text as a string. So let's code this much up and let's come back. So an encode function which accepts a key, original text, and returns the encrypted text, and a decode function which takes a key, an encrypted text, and returns the original text, right? And let's come back here now. And now let's discuss about how these functions should work. And now let's say we have the input text ABCD. The ABCD is a string which is represented internally in Haskell as an array of characters. So how can I convert this into B, C, D, E if the key is 1? And BCDE will be represented internally as an array of characters BCDE. And we know that we are incrementing each character by 3 places. So how can we do that? If I could convert each character to its ASCII value, and how can I do that? I can use the ORD function, which is pre-built in Haskell, which takes a character as input and returns the ASCII value of that character. Okay, I should be using this OR along with map and pass this array that or string as input, and I'll get this array of ASCII values back. And what I can do is I can again do a map function with plus the key along with this array to get back an array which is like 98, 99, 100, 101. And how can I go from here to here? Well, I converted this characters to ASCII values using the OR. Now I have the ASCII values and I need to convert it to characters. I can use the CHR function, which is pre-built in Haskell, along with the map function. And then this array of characters is basically, when you print it, it is basically a string, BCDE. That's how we are going to do the encode function. So let's do that right now. So let's code our encode function first. So it accepts a shifting key value and a message. And let the array of ORs, which is basically this one, be map ORD message. And let the shifted be map plus shift, which is basically the key with arts, and in map chr shifter. So what's happening here? First, I'm converting the string into the list of ASCII values. Then shifted is basically incrementing those ASCII values by the key, which is basically a shift value. And I'm mapping back the shifted, which is having the array of incremented ASCII values back to characters to get an array of characters, which is basically a string, right? And now how does decode function work? I remember I told you that it is basically, wait, I can do this. Basically, I can say decode, and instead of that, I can just put minus shift and it should work properly. But I don't need to do that. Why is that? Because I already have the encode function. So I can simply write encode MSG, and I can negate the shift value and pass it. So basically, decoding is basically encoding with negative shift value. Remember, just instead of adding plus key, I'm adding minus key. So I can just call the encoded function within the decoded function to get the result. So let's run it, right? So let's load this file up. And let's try giving it some inputs. Let's say like encode 1 ABCD. Say decode 1 BCDE. ABCD, we get back the original result. We can say encode 3 hey, and let's say decode 3 and this text, and we get back the original message. Congrats, we have successfully built Caesar Cipher in Haskell. See you guys in another video.